Everyone, we're about to start our reactions unit, and we're going to find that acids are involved in a lot of our reactions. So we're going to take a quick little moment here to learn how to name acids. Naming acids pretty easy once you learn the pattern. But first of all, let's talk about what an acid is. An acid is a molecular compound that begins with a hydrogen and has a bunch of other nonmetals. But weirdly, acids will ionize. So when you put them in water, they break up. And that proton, the H plus from the acid, will go over to water to make this ion we call hydronium. And then the negative anion will just be an aqueous ion floating around in the solution. Now, since every acid begins with H pluses, really they only differ by what is that H plus connected to, right? That anion. And so since the anion is really what makes their structure different because they all begin with a hydrogen, right, that they will lose to water, we name acids by what this anion is. Okay. So let's look at this pattern. Now, this pattern that I'm going to explain is on your reference packet, right? It is on your reference packet. So you don't have to memorize it. You just have to know how to use it. So what we're going to focus on is what is the name of the anion that will be produced. If the anion naming ends in ate, well, then what we're going to name the acid is an ic acid. So in this situation, if our anion was chlorate, being the chlor becoming before the ate, well, then what we would get is we change the ate to an ic acid, and now it would be still chloric acid. Okay. If the ending was in an ite, what we're going to do is change that not to ic acid, but to an us acid. And then lastly, if the ending is an ide, we have a chloride ion that's attached to a hydrogen. Now that's going to become a prefix hydrochloric acid. Now this pattern is going to become very simple to see once you do a little practice. So why don't you do a little practice with me? So here I have an acid. This is H2CO3. I can tell it's an acid because it's all nonmetals, and the first element in the formula is a hydrogen. Okay, so what's going to happen is this hydrogen is going to give off, this acid is going to give off two protons, two H pluses, and then it's going to release this CO3 2 minus ion. Well, what is the name of that ion? That ion is called carbonate, So my pattern, I look at my pattern, anything that's an 8 will become an ic acid. If it's an 8, it becomes an ic acid. So it's not going to be carbonate anymore. It's going to be called carbonic acid. The 8 becomes an ic acid, so we drop the 8 ending, replace it with ic acid, and we get our acid, carbonic acid. Let's look at this next one. I'm going to break it up into the proton that comes off of the acid, which is why this is an acid, and then what anion remains. What anion remains in this situation is the F1 minus ion, which is called the fluoride ion. The fluoride ion. Well, I'm going to look at my pattern. What does an ide turn into? An ide will turn into an whatever we're talking about, ic acid. So this is going to be a hydroic acid. Well, what is the thing we're talking about right now? We are talking about a fluor. So that is what's going to go in that gap there. And we're going to get a hydrofluoric acid. Okay, let's look at the next one. H2SO3. We have two protons that are going to come off, which means that this anion must have a -2 charge. So SO3 2 minus, SO3 2 minus is the sulfite ion. Sulfite. Looks a lot like sulfate, which is SO4 2 minus, but it's sulfite. So what does an ite become? We look back at our reference sheet. We see that any ite becomes an us acid. Ite is going to become an us acid. So this is going to become us acid. Well, what are we talking about? We're talking about a sulfur. So this is going to be a sulfate sulfurous acid as its final name. Not to be confused with this one. What do we have here? Well, we have another H plus, and an H plus is going to release. It's going to be released two H pluses when it's an acid. And then we're going to have this S2 minus ion. The S2 minus ion is a sulfide ion now, sulfide. What does ide become? Ide is going to follow the pattern of hydro, whatever we're talking about, ic acid. And what are we talking about? We're talking about sulfur again. That's what goes in there, the sulfur part. So there's going to be hydro sulfuric acid. Hydrosulfuric acid. One more down here. Again, we're going to break it up into the proton that comes off and whatever the negative anion is, ClO4 with a 1 minus charge. Okay, ClO4 with a 1 minus charge. What is that ion? Well, if you don't have it memorized, you look on your reference sheet and we see it looks a lot like chlorate, but with one oxygen more. So this is the perchlorate ion. All right, so per doesn't matter yet. We're going to use it still in the name, but we care just about the ending. This is the ate ending. Anything that is an ate is just an ic acid. Okay, so what are we talking about? Well, we're talking about the perchlor. Perchlor is what we're talking about, the perchlorate. So it's going to be the perchloric acid. Okay, now let's just go backwards, right? We're going to go and write the formula from the acid name. So again, just following the pattern, using the hints of the name to figure out what the ion was, and then we're going to figure out how many hydrogens are needed to make a neutral acid molecule. So if I was told that I had carbonic acid, I know that anything that's an ic acid came from the ion 8. So carbonate, carbonate. Carbonate is the CO3 2 minus ion. So how many protons, how many H pluses are necessary to have a neutral molecule with a carbonate? Well, that's going to be 2. I need 2 H pluses to get to 0 from that -2 ion. So what is my acid formula? H2CO3. Let's do this next one. Hydrocyanic acid. So we're dealing with a pattern that is a hydroic acid. That means the ion must have been the ide version of the ion. Because remember, we have these patterns right down here telling us what we have. So we had the cyanide ion, which is CN1 minus. So how many protons are necessary to neutralize that? Just a single proton, a single H plus. So our formula is HCN. We have another hydroic acid. We have hydroiodic acid. So if it's the hydroic acid formula of an acid name, then that means we're dealing with the ide. So what are we dealing with? We're dealing with the iodide anion, which is just an I1 minus. So how many protons are necessary? Another time we have just one because it's a 1-to-1, +1, -1. So we have an HI as our acid formula. Okay, one last one. Now we have an us acid, phosphorus acid. Now, if I have an us acid ending, that means my ion must have been the ite version of the ion. So what we have here is phosphite. Well, what is phosphite? Well, phosphate is PO4 with a 3 minus. So this is going to be PO3 with a 3 minus. That's our phosphite ion. Now, how many protons are necessary to neutralize that? Well, I need 3 protons to neutralize that phosphite ion. So this is going to be H3PO3. Okay, this is much better with practice. So hop on to Active Chem and do your practice for homework.